Okay, here we go. We are ready to get ready for your semester exam for the fall semester. So that way you can make sure you pass. Let's look at the first slide, shall we, and answer some questions. Okay. Wow, that didn't happen. But anyways, yes it did. So okay, let's see. Take some drawing and say do something simple like name a line that contains points T and Q. You can see there that you have these little letters at the end. Those would be the, you can name the lines like that and say line H. Or you could say based on the letters. So T and Q or QT, RT, and RQ. Anything like that would work, or some variation. Now keep in mind that you will have a multiple choice, so that's why I'm giving you the multiple options here, because you're not sure which one of those you can get. So there's multiple possibilities here. Make sure you find the right one. I have no idea what these directions are, so let's just not worry about those. And then let's see, AK and CG intersect at what point in plane T? They intersect at point M, sir. Well, duh, I can see here. Obviously, AK, CG, ooh, that was a horrible thing. Let's do that again. Ba-ba. They intersect there at M, because M's going, yay, I'm in there in the middle. Alright, so there you go. Find the measurement of each segment. Figures are not drawn to scale, because, well, you need to know that. Anyways, what matters here is that you're just going to make sure you add the two. So you add those together and go plus, so 18.4 equals 23.1. Now, if I turn that around and said, find, like, say, a smaller segment or find the larger segment, and I gave you the total, you would make sure you would subtract. So, again, should be fairly easy. Name a pair of segments that are congruent. Wow, what could those be? Could I make it more obvious with, say, the little congruent marks there? Could it be AB? I'm sorry, AD and BC, sir? I think it is. That one should be easy, guys. I'm not gonna even, gosh, if I have to tell you something about that, that's just sad. Oh, with the bells. Use the number line to find the distance of each segment. Again, you can see here from R to T, it's like, the idea here is that we would say 4 minus a negative 2. That would tell you it's 6. Again, keep in mind it's always an absolute value. When we talk about distance, it's always positive. So this would be 6. That's pretty easy. You could always count 1, 2, 3, 4, 5, 6, and that would get you there. What happens if I ask for the midpoint? Well, the midpoint would be halfway. So half of 6 would be 3. So it'd only go a distance of 3. That would be at point S. But if I ask for the coordinate, I would want the 1. So that would be at that 1. So I will tell you this. On my semester exam, we do have that. I'm looking for the coordinate. So it's going to be the number, not the letter. Okay, for your note sheet, you can add this little bit about the midpoint formula. X2 plus X1 divided by 2, Y2 plus Y1 divided by 2. That's just the midpoint. You take the two X's, you add them up, you divide by 2. You take the two Y's, you add them up, you divide by 2. Simple as that. If you need to remember, so on this one for number 6, we had the points negative 9, 3 and 5, 7. So you see here I can combine the negative 9 and 3. I'm sorry, negative 9 and 5, and the 3 and the 7. Why did I put... So you get an answer of 2, 2, and that's it. Now, again, for those of you who are using the Inspires, keep in mind I use Control Divide to get that fraction symbol. Maybe that would help you with that fraction symbol, but we'll see. I have no clue. Do not forget, you can use a note sheet. I would put that midpoint formula on there. Alright, so what is the vertex of an angle? Name the vertex of the angle, each angle. That's simple. When you see 3 letters for an angle, like say angle POM, the vertex would be the one in the middle. So this one's point O, or the vertex would be O. So kind of keep that in mind. If you need a reminder, put that on your note sheet of some sort, like let you know that the middle letter is the one that's the vertex. Duh. Alright, right acute obtuse, y'all should know that. Acute, right, we have to see the 90-degree angle, so you got to see the little square. Acute, you're going to tell it's small, and obtuse, you're going to see that it's larger than 90. Okay? If you need to write down directions or definitions for that, go for it. So, alright, linear pair. Something else to add to your note sheet. Linear pairs, two angles next to each other that add up to 180. So when I look at this one and go back here, if I want to see if it's a linear pair, I see MQN, that's this one right here, PQR, that's that one right there, and they are not next to each other. They're kind of opposite of each other. Those are actually vertical angles. So this one is a no, they're not a linear pair. Now, if I was looking at that one and I said MQN, I could have gone NQP, that would have been a linear pair, because that would have given me like that. Anything like that would have given you a linear pair. They have to be next to each other on a straight line. Making conjecture about the next item, well, that one should be pretty easy. Basically, you just got to make sure you're adding. So that one's pretty easy. Just tell the pattern. I don't think that's going to be hard. Okay, this one might be a little bit more difficult. Here I'm telling you this is a right angle, so what do you know? Anything that's a right angle, if you got two lines, minimum you should be able to tell is that the two lines are perpendicular. So I could say here, I can make a conjecture that AB and BC are perpendicular. Or you could have said ray BA and ray BC are perpendicular. Anything like that would have been fine. Also, you should be able to identify hypothesis and conclusion. The if statement is your hypothesis. The then statement is your conclusion. Easy peasy. Those should be easy. Okay, so for converse statements, I would make sure that you know that with a converse, we're basically switching the hypothesis and conclusion. I would put that into my note sheet. So this right up here would go into my note sheet. I don't think we have anything with inverses or contrapositives. So you just worry about the converse. Switch the hypothesis and the conclusion. So if I study for my geometry final, then I will pass my semester exam. Switch that. If I pass my semester exam, then I studied for my geometry final. That's it right there. Something simple like that should work. Okay? Don't overthink it. Should be easy. It's going to get there in a minute. Yay! Okay, so make sure you got that down. Okay, law of syllogism. What is the law of syllogism, sir? If A, then B. If B, then C. Then that means if A, then C. So basically, you're seeing that B statement as a joiner. So on number 14, we talked about, and I don't have that question in front of me, but you should have your final right in front of you. If two angles form a linear pair, then it says they are supplementary. If they are supplementary, then the sum of the measures add up to 180. Well, we're being joined by that part that this says they're both supplementary, so we can say if two angles form a linear pair, then their sum of the measures is 180. That's all the law of syllogism is. It just kind of joins two. It takes like two sentences, puts them together in one. And there's some type of common thing that they can join them. Simple, right? I know y'all are going to do awesome on this because y'all are just going to be awesome. Now, the other one is if a hurricane is a category 5, then it has winds of greater than 150 miles per hour. If the winds are greater than 150 miles an hour, then trees, shrubs, and all that. So join that. If a hurricane's category 5, trees, shrubs, and stuff like that are going to get blown away. That's all the law of syllogism is. It's pretty simple. Y'all should do well with that. Or blown down. Anyways. Okay. You might want to make sure you have some of these properties. Reflexive, A is congruent to A. Symmetric, if A is congruent to B, then B is congruent to A. Transitive, if A is congruent to B, and B is congruent to C, then A is congruent to C. Definition, you might want to know your definition of midpoint theorem, maybe put in substitution property, segment addition property, things like that. So when you look at number 16, that one was just a midpoint theorem because it says, or midpoint definition of a midpoint, because it says if so-and-so is a midpoint, then these two segments are congruent. Number 17 is going to be transitive. Number 18, the first 18, which should have ended with then y is congruent to q, I'm going to say symmetric. And the next one is substitution, and you can tell substitution because you put something in place of something else. Like, I mean, if it says angle A plus angle B is equal to this, and then angle A plus 20 is equal to that, then angle A plus 20 is equal to that. Well, I put 20 in place of B. That's kind of like a duh, I'm putting something in place. And then finally, number 19 is segment addition postulate. So know that. I mean, basically, if you see something that says, I'm adding two segments together to give me the big segment, oh, there you go. It's segment addition postulate. It's a kind of a duh. Alright, number 20 is going to be the symmetric property. Let me look at number 20 again. Okay, so number 20 says if AB is equal to CD, then CD equals AB. So obviously C is basically saying two things are equal to each other, forward or backward. Okay? Simple, not hard. Y'all can do that.